Thermal energy is one of the most commonly used concepts in thermodynamics. In this video, we'll try to look at problems involving thermal equilibrium. Heat is the flow of energy from a high temperature to a low temperature. Thermal equilibrium is achieved when these temperatures balance out or heat stops flowing in the system or set of systems. Let's say, for example, I have here a piece of metal and water with both of them having their initial temperatures. Let's say the initial temperature of the metal is higher compared to the water. What will happen if I'll mix them together? Since they have different temperature, heat will flow from the metal to the water. This will continue until they reach equilibrium. At equilibrium point, their temperature will be the same. This setup will tell us that some energy from the metal will be lost and this exact energy will be gained by the water. And the first law of thermodynamics states that for a system to gain energy, work must have done to it. Or simply we can say that the sum of all the thermal energy here is equal to 0. It includes the energy lost by the metal and the energy gained by the water. Before we continue further, let's have a simple review. Specific heat capacity is the amount of heat energy added to 1 unit of mass of the substance in order to cause an increase of 1 unit in its temperature. Here are the list of the specific heats of common materials. Let's concentrate on the liquid water. Let's say I have 1 gram of water with an initial temperature of 25 degrees Celsius. If I will add a heat of 4.18 joules to the water, we will observe an increase of 1 degree in its temperature. That is also true with other materials, but take note they have different specific heat. And to compute for the specific heat, we have here the formula C is equal to Q divided by M times the change in temperature. This formula is probably well known in its form Q is equal to M times C times delta T, or the final temperature minus initial temperature. Now let's try to look at this problem. If 0.20 kilograms of water is poured into 150 grams of aluminum cup initially at 25 degrees Celsius, what will be the common final temperature of the water and the cup when equilibrium is reached, assuming no heat flows to the surroundings? Let us not forget that after the mixture, they will have the same final temperature. The initial step here is to identify all the given and identify what we are looking for. A table like this will help us organize the given, convert kilograms to grams, so that it would be the same with the specific heat. In this example, the heat gained by the aluminum cup is the same as the heat lost by the water. As we have said earlier, the sum of all the thermal energy is equal to 0. And therefore, the heat lost by the water plus the heat gained by the aluminum cup is equal to 0. We will be using the specific heat formula. So, the mass of water times its specific heat multiplied by the change of its temperature plus the mass of the aluminum cup multiplied by its specific heat times change of its temperature. All of this will be equal to 0. So plugging all the values, we have 200 grams times 4.18 joules per gram degree Celsius times TF minus 95 degrees Celsius, that's for water, plus 150 grams times 0.9 joules per gram degree Celsius times TF minus 25 degrees Celsius, that is for the aluminum, is equal to 0. So 200 grams times 4.18 joules per gram degree Celsius is 836 joules per degree Celsius. Take note, we cancel the grams. In the side of aluminum, we have 150 times 0.9 that is equal to 135 joules per degrees Celsius. By further simplifying this, we end up with 836 joules per degree Celsius TF minus 79,420 joules plus 135 joules per degree Celsius TF minus 3,375 joules is equal to 0. Next step is to combine all the like terms. And finally, we can solve now for our TF. The final temperature is equal to 85.27 degrees Celsius. Now, what if we have more than two materials mixed together? Let's try this one. 0.1 kilograms of iron metal was added to 700 grams of water, which is held by a 1 kilogram aluminum container. The initial temperature of the iron is 200 degrees Celsius, while the water and the pot are at 30 degrees Celsius. What is the final temperature of the system? The specific heats are also given. And again, after the mixture, we will only have one common temperature for the three materials. We can organize all the given in this table. And take note that we need to convert all the kilograms to grams so that it would be the same with the specific heat. In this example, the iron will be losing energy while the water and the aluminum container will be gaining the energy lost by the iron. As usual, all of this thermal energy will be equal to 0. So, the heat lost of iron plus the heat gained by water plus the heat gained by aluminum is equal to 0. We'll be using the specific heat formula as usual. So we have 100 times 0.45 times TF minus 200, that is for iron. I won't be writing the units so that it will fit in our board, but do take note that the units are very important when you're solving. For the water, we have 700 times 4.18 times TF minus 30. For the aluminum, we have 1000 grams times 0.90 times TF minus 30. All of this is equal to 0. We can simplify this by multiplying the masses and the specific heats. And after which, you multiply it by the change in temperature. Then, you need to combine all the like terms. And finally, you can solve now for the final temperature. Our final temperature here is equal to 31.98 degrees Celsius. And that's it for this video. I'll see you again next time. Happy solving!